Let's look at what I'll be referring to as a mole map from moving forward from today. And a mole map is kind of the pathway we'd use if we're doing any kind of conversion from atoms or molecules to grams to moles. It's the pathway that we go through when we do any one of these types of conversions. So let's have a look at the mole map here. And the mole map should be on the sheets I've given you in class. But this mole map kind of shows us the pathway we would go through to do any of these conversions. So if we have grams of something, we can go to moles of it by either to go from grams to moles, we would divide by the molar mass. So to go from here to here, we're dividing by the molar mass. If we have moles and we want to go to grams, then we're multiplying by the molar mass. So these are the conversion factors. If we have grams, then we'd say there's 1 mole per whatever the molar atomic weight of that is. If we have moles, we want to go to atoms, we're just going to multiply by Avogadro's number. If we have atoms or molecules and we want to go to moles, we're going to divide by Avogadro's number. So if you have moles, you can go to atoms or you can go to grams. If you have atoms or molecules, you can only go to moles, and then you'd have to go to grams. So it'd be a 2-step process. So if you're in the middle in moles, you can go in either direction. If you're at grams, you have to go through moles first. If you're at atoms or molecules, the only place you can go is moles. Right? And so these are the conversion factors going, this one would go this way, this one would go that way, this one would go that way, this one would go that way. So if we ask ourselves, how many copper atoms are in 5 grams of copper? We'll work through this problem using the mole map, right? And so what our known is we have grams of copper and we want to go to atoms. So if we look at our mole map, we're on this end. So we're going to have to go to moles and then to atoms. So if we kind of draw where we're going, we have grams of copper. And we're going to want to go to moles of copper. And then we need to go to atoms of copper. Right. And remember, for each of these arrows, that means we need a conversion factor, and these are the conversion factors we're going to use. So if we start with grams of copper, we have 5.0 grams of copper. We're starting with has to go on top. We want to go to moles of copper, so we need to know the relationship between moles of copper and grams of copper. Remember, that relationship is found on the periodic table. So if we look at your periodic table, that relationship is right here on your periodic table. And we'd find copper and see that 1 mole of copper weighs 63.55 grams. Okay. So that's just the atomic weight from the periodic table. So you can see we're saying 1 mole of copper is 63.55 grams of copper. That number would change, and it's different for each element. Right? Now we need a conversion factor from moles of copper to atoms of copper. Right? So we need to know that 1 mole of copper contains 6.022 times 10 to the 23 atoms of copper. Right. And again, what we're going to do is we're going to multiply everything on the top and then divide it by everything on the bottom. And you should find out that you have 4.74 times 10 to the 22 atoms of copper. Right. So that would be going from this side of your mole map all the way to the other side. So let's see what happens if we want to go in the opposite direction, right? So say we want to know, how much does 6.022 times 10 to the 23 atoms of copper weigh in grams. And those of you that are picking up on this quickly could probably answer that very quickly without looking up anything that we didn't already look up. But we're starting here now with atoms of copper. So on our path, we're going to go the opposite direction. We're going to go from atoms of copper to moles of copper, and then to grams of copper. Right, so we're going to need two conversion factors, and these are the conversion factors we're going to use. So we're going to say we have 6.022 times 10 to the 23 copper atoms to start with. That's a 0. Right, and so now we need a conversion factor to go from atoms to moles, and we know that 1 mole of copper contains 6.022 times 10 to the 23 copper atoms. Right, so going from here to here, we're dividing by 6.022 times 10 to the 23rd. Now we want to go from moles to grams, so we're going to multiply by the molar mass. So we need to know how many grams of copper there are in every mole of copper. Right. And we just looked that up on our last problem from our periodic table, but again, you would go to your periodic table, find the symbol for copper, Cu, and see that its atomic weight is 63.55. Right, and so now we have our atoms of copper canceling our moles of copper, and all we're left with grams of copper. And you can see this divided by this is going to be 1, so we're just going to be left with 63.55 grams of copper. So that's how you would go in both directions across your mole map, and you'll probably need to practice that quite a bit.